Thank you, Liliana. Let me first see how this works here, so I can simply go back. Okay, perfect. So good morning, everybody. My name is Geert Verhoeven. I is what they would call the coordinator of Project INDIGO. And today I want to talk a little bit about the things that we have developed over the 2-year project. So my talk is therefore called, is there a pointer here? I don't know if maybe I can use this one here. So from street to schema, which means how do we turn the stuff that we see in the street into a metadata schema so that we can then use and query these data later as well. So before INDIGO started, I think there were 2 assumptions for this project, is that graffiti are unique, they are complex and short-lived and socially relevant, but they are unique, complex, short-lived, socially relevant cultural heritage, because if they would not be cultural heritage, our efforts would be a bit in vain. And the second assumption was that the potential of graffiti to understand society is underexploited. As an archaeologist, we often study Roman graffiti or Greek graffiti, but it's almost unthinkable of that people would study contemporary graffiti, although the framework in which it appears is nowadays much better known than the Roman frameworks. So we started Project INDIGO. INDIGO means inventory and disseminate graffiti along the Donau Canal. The first part says what we are going to do or what we did. The second part says, or the last part says where we did this. And the idea was to digitally preserve all this graffiti and also to analyze this graffiti, or at least create a framework that would allow other researchers to analyze all this graffiti. We did this with quite a few partners. You see most of the partners here. The money came from the Austrian Academy of Sciences, so we got about 580,000 euro, which I could employ several people to work on this project for 2 years. So the idea of this whole project was, let's have a look at the Donau Canal. So we are here in, this is Austria, we have Vienna, and in the city center of Vienna you have the Donau River, the Danube River. And there is a canal, a side arm, which is the Donau Canal, which also runs to the city center of Vienna. And the idea was to go from this bridge to this bridge and document all the graffiti that is daily sprayed there. And then to make a virtual platform where people could virtually walk along the Donau Canal, but also you could slide through time. And you would have all the data available for analysis. Now, I can already say this is a very ambitious goal, and we did not reach that goal because we saw that a lot of building blocks have to be built before we can even reach that goal. For instance, one of the main things was we want to make sure that when we create this database and this platform that people can ask queries, and these queries can be asked by archaeologists, but they of course are interested in other things than art historians or linguists, so we have to make sure that this database allows for all of this. We already have the name for our platform. It will be Urban Chameleon, and so everything I will be talking about are the tools that we developed to hopefully in the next project. So I've written an INDIGO 2.0 follow-up project. We don't know yet if this will come to fruition, but the idea is that we build upon all the building blocks that we developed in this first project to then hopefully finally make this platform a reality. So the INDIGO project was built upon 5 pillars. We did not create graffiti ourselves, but we acquired photographs of graffiti. We processed those photographs. We managed those photographs. And the acquisition and processing stage is what I call the documentation of graffiti. The processing and management is the archival stage. And together they form the inventorying stage, so the first part of the acronym. And then we want to disseminate this with this platform, but not only just disseminate so people can virtually walk along the graffiti, but also give researchers, whether they are sociologists, criminologists, the tools to really analyze this graffiti. And this is where everything starts and ends, right? Because the platform has to allow all the analysis that we envision. For instance, one of the questions could be, along the Donau Canal, where do pieces occur that are created with aerosol spray paint, which crews made them between 2021 and 2023, and what are their main colors and typical size. So this means that we have to know exactly where the graffiti was located. We have to know exactly when it was created. Oh, sorry, this was a bit too far. We have to know that we are talking about the same thing, so we have to agree on terminology. And we have to find ways to properly characterize this graffiti by size, by colors, and by other attributes. And the main thing that, and a lot of research happens, is that you build a local database, okay? But my fear, also as an archaeologist, I very often see this. Colleagues, for instance, in Belgrade would make a database, colleagues in Brussels would make a database, and I in Vienna would make a database, but these databases do not talk to each other. And this is one of the main things. I want that if we do this in such a way that if our colleagues in Belgrade would do this, and they would make a database, that we can ask these queries to 2 different databases, so that these databases talk to each other. This means that everything that we want to do in INDIGO should become a kind of standard. So this was my high aim, to do it in such a way that this could become a standard for graffiti research. So let's focus on a few results and the products that we created. So how did we find out about the location of the graffiti? So the first thing that we did is, okay, we photographed everything from the Friedens, or the Bridge of Freedom, until the Verbindungsbahnbrücke, which means the bridge that connects 2 parts, so it's a very uninspiring name. And so this was the INDIGO research zone. And the nice thing about this graffiti there along the Donau Canal is that you have 2 banks, so the left and the right bank, but you also see that we have a part below the walking surface and just above the water and above the walking surface. So if we count everything together, so left and right and up and down, we end up about with 13 kilometers of uninterrupted graffiti. So this is with all the bridge pillars, all the staircases, and so about 13 kilometers of graffiti that we tried to monitor. A short question for the people that are not of Vienna: how many of these 13 kilometers do you think are legal? Less than 300 meters. But it's so accepted in Vienna that almost everybody, even Viennese people, think it's legal. Okay, because people would just be spraying there during the day. So yeah, the first thing that we did is we photographed everything, a little bit bigger than our research zone, but we photographed everything for a few specific purposes. Okay, so this is the entire zone that we started to photograph. So how did we do this? We photographed once from this side, so that we mainly had this part and this part in a bit less detail. And then from this side to have these walls here in detail. So in total, this was about, let's say, 27,000 photographs, which we then processed into an entire 3D model. So all the blue squares you see here are where we took the photographs from. But this is still not georeferenced, which means you cannot measure or you don't know where you are in space. And to do this together with a colleague of the Technical University of Vienna, Benjamin Wild, who will later present today, we went along the Donau Canal, and at 21 positions we put our total station, and we measured what we called graffiti-scape points. So these are points that we know, even if they are oversprayed, we will still see them in the photographs, and we have millimeter accurate coordinates of those. So with this whole network of 28,000 photographs is positioned millimeter accurately in the Austrian coordinate reference system. Okay? And this serves 3 purposes and is the backbone of the INDIGO project. So first, we can make an entirely 3D mesh surface out of this, so a closed surface. So this looks like this, okay? And here is the water. This also documents the graffiti status quo, so we did this at the very beginning. So from there onwards, we started documenting. And it helps to position new images. So thanks to all these photographs, we can now have technology to position new photographs that we take. How was this done? I'm not going to a lot of detail in this topic because Stefan, my colleague, will talk more about this. But the idea was that we used a monitoring app and Instagram to find out where new graffiti was created. I write 2 photographers, but let's say it was Stefan 99% of the time, and when he was on holiday, I took a few photographs, but mainly Stefan photographed everything. And we had 2 cameras, 2 tablets, also 2 spectrometers. So for every photograph, we also measured the solar illumination, because one of the things that we wanted to achieve was color accuracy. So we have to know the exact illumination at that time. And we had a very fixed acquisition procedure. Again, I will point to Stefan's talk for more about this. One thing I have to say is that when you take new photographs, okay, the software then has to find, okay, where to position these photographs. And it does this by trying to find identical points between the new photographs and the existing network of 27,000 images. But of course, this takes very long. So if you can confine the box in which you search, this helps really a lot. And you can do this with a standard GPS system. But these are not so accurate, let's say 2 to 10 meters. So we developed our own system. This is a hardware component that we developed in Project INDIGO. It fits onto the camera. It is steered by our phone or by a tablet, and it gives centimeter accurate coordinates for every photograph that we take. Okay, so it gets real-time real-time kinematic correction signal. So it gives us very accurate photograph positions, and with this, if we take, let's say, first photographs and then we take new photographs, we can very quickly put them at the correct location again, thanks to this backbone of 27,000 images, so that we can very quickly see how a landscape, the graffiti scape, changes over time. To do this, we use a software which is known, which is called Metashape, but we developed our own plugin for it, and everything I can already say that we develop is free and open source available online. So our software is called Autograph. It was programmed by Benjamin, who will talk about it later. And Autograph finds the photographs that we take and puts them at the correct position, but also automatically makes orthophotographs of this. What are orthophotographs? If you have a photograph like this, you see that the scale is varying, and you cannot really measure on it, but with our software we can automatically turn this into a scale-accurate photograph, where every pixel is millimeter accurately located somewhere along the Donau Canal. Okay? Just some information about the amount of photographs that we acquired. So we did 2 of these total coverages, one at the start of the project and one at the middle of the project, for a total of about, the first one was 27,000, the second total coverage was 42,000 photographs. Stefan was also extremely, let's say, busy with 106 times walking along the Donau Canal, so every 4 or 5 days he would walk and find new graffiti, which resulted in almost 100,000 new photographs. So that's a lot of photographs that have to be tagged with metadata and have to be anonymized, because if you put them online, nobody should be visible on these photographs, and so forth. So this is the location part. I want to then talk a little bit about the temporality part, because this is something that is also very important in archaeology or in graffiti research, but it's seldom talked about because it's very hard to work with temporality. And it's something that we started in INDIGO in the project, but we would like to continue in INDIGO 2.0. So what I will be showing you are just a few hints at what we think could be possible, okay? So to start a thought experiment, let's say that we take a photograph of contemporary graffiti at this moment in time, and another person takes this photograph of a Roman wall painting and graffito here as well. Now, for the Roman wall painting, you would never say that the moment the photograph was taken is when this graffito was created, right? But for contemporary graffiti, we very often say that the moment we took the photograph is more or less the time that the graffito was created. So it's a date and time, it's a creation event, this date here, and in this case, we would never say it is, let's say, the creation of the graffito. In this case, we often would say, but in both cases, it's not exactly the creation of the graffito, it's really the creation of this photograph. Because even here, this could have been created a few days or a few weeks before. And this is a very important distinction, which I will touch upon later, is that when we make a database with metadata, the metadata that describes the graffito is different than the metadata that describes the photograph. And this is something that most databases do not distinguish, but we think it's an essential distinction. But like I said, I will talk about this a little bit later as well. So how did we go about storing time? We first tried to find out, okay, what are the ways in which we can partition time? So in situ, there are a few events. A graffito is produced, it gets modified, maybe partly oversprayed, and it can be never destroyed, but sometimes the wall can also be completely destroyed. So the state of the entire graffito is either visible, completely or partly, or at a certain part it becomes invisible. And this whole time span is what we call the existence of the graffiti. So only when the wall is destroyed is the graffito also completely destroyed. And we try to get information about all these different points in time by our observations, which means all these tours that we do along the Donau Canal to photograph. Okay, so how do we do this? This is something that we want to do more in INDIGO 2.0, is for every graffito that we photograph have this type of structure, so an additional file in the database. And I just want to focus on the visible part to see how this would be populated. Ideally by software that this is completely automatic, but the reasoning would go like this. Okay? So we have a start, we have an end date, an earliest and a latest for each, and a span. So how long was this graffito really visible? So to give you an example, let's have this example here. You see the date when Stefan took the photographs. So you see just in a matter of days how much change happens there along the Donau Canal. So let's say we want to focus here on this Zelensky graffiti and we want to find more out about its temporality. So we can say we took the photograph here, so this is the absolute latest time that this graffiti was created. The moment that Stefan took this photograph, it was not there, but it could be that 1 minute later it was sprayed there. So we can say the earliest start is the time that we took this photograph. And the same reasoning we can use also for the end date, okay? So the earliest time that it would end is this date, because it could be that 1 minute after Stefan took this photograph, somebody oversprayed it. Of course, we don't know. The next photograph we have is here, but here it's completely oversprayed, so here we know this is the absolute latest date, because it could have been sprayed just a minute before we took that photograph. So from this we have a maximum and a minimum time that a graffito is visible, and if we do this for all these tens of thousands of graffiti that we create, we can really start temporally questioning how long does stay something visible, and what does this mean for the graffiti that stayed longer or less long visible, okay? Good, so this was concerning temporality. Then about characterization, we were thinking about a few things. One of the first things is, like I said, graffiti is very often characterized by its color, but we want to make sure that color is accurate. So we developed quite a lot of ways of how we photograph the graffiti, but we also developed our own toolbox, which is called CoolPy, to process photographs in a color-accurate way. Of course, this is not direct, it's easy to use, but you still need to know a little bit what you're doing, but this allows us to get the most accurate color from our cameras that we can. And then the next step, which is something that I started programming, but it's not finished yet, so this will be something for INDIGO 2.0, is how do we characterize the colors? Because if I have a photograph and I show this, let's say, to Liliana and to Stefan, and I say, which color is this? Liliana might say, I think this is dark purple, and Stefan might say, this is blue. Okay, but what do we put in the database? Because if we look for blue, we will not find it if Liliana did the classification. If you look for purple, we would not find it if Stefan would do it, right? Or if you look at one photograph, even myself, on different monitors, as you know, or different televisions, the colors will look a bit different. So we try to objectify this. Again, the software is not available yet, but the main functionality is there. The way that it would work is like this. So we have a photograph. We first run an algorithm to remove a very small detail here. Sorry, I have to go back. So all the small detail is first removed. Then we do a color segmentation. Then we group colors that are very closely together, like this. And from this we can then extract all the colors that make up this graffito. And we have then the unique color code, but also we are building a thesauri where we have, if we say this pixel had this and this and this value, it's uniquely that color. So in that way you can uniquely define colors of your photographs, which could, as Liliana said, have implications beyond graffiti research, but everything that is done in art research. Okay, so far we talked about location, temporality, and characterization, and all this is what I would call metadata of graffiti. So it gives extra additional information about the graffiti or about the photographs that we took of that graffiti. And like I said, this is one very important distinction for us, because just as the creation date and time of the photograph is different from the graffito, the same is with the author, because the author of this photograph is Stefan, but the author of this graffito is not Stefan, okay? The location is different. Stefan is standing here, the graffito is here. So we have to distinguish between these things. So this is why INDIGO had this core division from the beginning in the database, where we say, okay, the graffito is the real world physical resource, and then we have all kinds of digital resources which are approximations in the virtual or the digital world. Digital photos, textured 3D models, orthophotographs, and each of them have their own metadata. And sometimes, I will show an example later, the metadata that we extract from these digital products, like our photographs, can inform about the metadata of the real graffito, but at the end of the day, what are people interested in? They are interested in the real graffito. We cannot show this online because it's in the physical world, so we can only have the metadata of this graffito. What we can show online are the photographs and the texture 3D models of this graffito. But people are not interested in who made these photographs really. So what really ends up in the database are these digital approximations and the metadata that describe the real graffito. So this should be part of the entire virtual platform that we envision. And like I said, the metadata, we made our metadata schema to keep all the information that we think is relevant for all kinds of research. So we have to think about which language is this for linguists. We also have to think about the location. So all these different things are stored in specific metadata fields. And how this would work is like this. So let's say we have metadata at the graffito and at the image level. So here the identifier would be a unique number for both of them, okay? Here the author would be Vox Inc. and the author of the photograph is Stefan. The date that Stefan took that photograph is known. So from this date and the previous tour that he did, we can say between this and this date, this graffito was created. The location, as you see, is slightly different because Stefan is standing in front of the wall. So as I said, everything that we have in our database is millimeter accurately positioned. And then we can have additional information like the technique, the style, and the colors. And for the photograph, we could have things like which camera, which shutter speed. And also in the photograph, we then say, okay, which graffito is depicted. So it's this graffito. And then we know, okay, if you want to more know about this graffito, here's all the metadata of this graffito. But one of the problems that we had, I suppose that you can imagine, if you take a photograph of a specific graffito, you end up with multiple graffiti. Because all this metadata here refers only to this part, not to this, not to this. So how do we deal with this? So we need a way to segment this image to make sure that the metadata we are talking about is exactly tied to this polygon here. So we developed software to do this, also freely available, so you can segment your images and add specific metadata to it. And the powerful thing of developing our own software is then the following. So here we have everything in pixel coordinates. But this software sends the data to Autograph, which makes a 3D model of it, which can texture the 3D model, and which can also project a polygon on there. And now we have the polygon millimeter accurate in real-world coordinates, so we can automatically find out the area of this, so how large this graffito is. So this is what I meant by saying sometimes we find information about the graffito from the digital products that we generate from it, okay? And then the last thing I want to quickly talk about is this here. As I said, one of the main important things is to make sure that when we ask a question to our database that we know we are talking about the same thing. So their terminology is important. And to make sure that we would, let's say, all talk about the same terminology, we thought, okay, what can we do to do this? And we started brainstorming. This is something that I thought would take a few weeks. It has taken us 2 years and it's still not finished, okay? Because one of the things is, okay, you have terminology and hierarchy. For instance, most people would say this is a graffito, right? Many people would say maybe this is maybe rather street art, but what about something like this where you then have everything together? And if we agree on the label, is this graffiti street art? Do we say that street art is a subcomponent of graffiti? Is graffiti a subcomponent of street art, or are they both individual entities living next to each other? And if we don't solve this, people that would look for street art might not find graffiti and vice versa. So we try to disentangle this by reading lots and lots and lots of literature, and the more we read, the more we saw that there is no uniformity across the literature whatsoever. Okay, so we still try to come up with what we call a thesaurus. A thesaurus is a list of terms that has synonyms, that has preferred terms, and also unique links. So our thesaurus so far was mainly an effort by Stefan and by Jonas Schlegel, which was another colleague of mine. And the idea is that we have a hierarchy of terms with synonyms and preferred terms. So even if you have several terms for one, we say this is the preferred term. They have a unique resource identifier, so which means if somebody wants to use a specific definition, they can say we use the definition that INDIGO made. They give this URI, and the whole semantic web technology knows exactly what this definition means. And then it is, how do you structure this thesaurus? And we tried many different structures. I don't know how many we had together with Stefan, 6, 7, 8. And at the end of the day, we thought, okay, would it not be best to take the biggest thesaurus in the world of art and architecture, which is the Getty Art and Architecture thesaurus, and we made sure that we stick to their hierarchy. Is this perfect? Maybe not, but at least our thesaurus can now be mapped one-to-one to the Getty thesaurus Art and Architecture. The only thing that we did not do yet is have perfect definitions for every term, because this is something that I think should be very, very meticulously crafted. We also want to have illustrations for every term, so this is something that we hope to then do in INDIGO 2.0 if we get the money for this. But at least we already agree on synonyms, preferred terms, and hierarchy. So as a kind of wrap-up, what did we produce so far in INDIGO 1.0? So we have 3 software packages, Autograph, CoolPy, and Graphis. I wrote 3+ because we have also many smaller scripts that we don't see as full-fledged software packages. For instance, the book of Lisa Gottlieb, where she has identified different styles in graffiti. We made a small graphical user interface where you can directly visualize her text. And the idea is that we would also apply this to all the other styles in graffiti to more or less objectify graffiti, so that, let's say, if any of you would say, we have an image of graffiti and we would like to say, okay, is this now a tag or not, that you would say, okay, it has this and this and this property, and the software would automatically say, okay, then it's this classification. So the whole idea behind everything we do is to objectify the database, okay? We developed one hardware component. We had 6 peer-reviewed articles and 15 conference publications, which is quite a lot in just 2 years. I mean, a few of them were then written after the project, but still we were extremely productive there. And we have 5+1 data set, so we have 2 thesauri. We have also an image change detection data set, and one data set that I'm still continuously working on is this graffiti database. So all the new literature that becomes available, I put in this database, whether it is books or articles. Right now we are at 2,100 references so far. Sorry. We had 29 talks. This is the 30th talk. We had 4 posters. We did 2 symposia, as Liliana already mentioned, which was very nice because we there brought graffiti creators and researchers together and we made them discuss, which was a revelation for both audiences. And yeah, these 2 proceedings are freely available online. So everything you will find on our website with all the links and so forth. This is of course not work that I only did, so this is the entire team of INDIGO. So we have Stefan, later Benjamin, but many different people worked on this project. And yeah, this is more or less everything I wanted to say to you. Thanks a lot.